I finally solved it!
Wait, good job! Isn't it so fun to solve math problems?
Yes!
You know, it seems like nobody's calling us.
It's actually a good thing. We can finally rest.
True.
It's true.
I wonder when we'll receive our next call.
What a great coincidence!
And that was good.
Hello? Hello, is this the Easy Math hotline? I'm actually having so much trouble with my physics homework and I don't really know what to do anymore. Can you please help me right now? Thank you.
A ball was held and dropped from the 14th floor of Henry C. Building. It took 5 seconds for the ball to reach the ground. Find the final velocity before it hits the ground. The equation to be used here is Vf equals Vi plus Gt, wherein Vf is the final velocity, Vi is the initial velocity, G is the gravitational force, and T is the time. The equation here is a linear equation because the degree of the variable is 1. The dependent variable here is the time and the dependent variable is the final velocity. Now, if we substitute the given values to the equation, we get Vf equals 0 plus 9.8 times 5. And by calculating that, we get that the final velocity of the ball is 49 meters per second. Now for the graph. Since there is no negative value of any velocity, we'll only take its positive values. With that in mind, the x and y intercept is 0, 0, or the origin. Its domain is 0 inclusive to positive infinity, and the range is also 0 inclusive to positive infinity. Now I'll give you a similar problem. A ball was dropped and its final velocity before it hit the ground was 588 meters per second. What time did it take for the ball to hit the ground? Now, to solve this, we need to substitute the values again. By doing this, we get 588 equals 0 plus 9.8 times x. And by dividing 9.8 to both sides, we isolate x and we get 60 seconds or 1 minute. And it's done.
A light bulb is placed at a distance of 50 centimeters from a convex lens having a focal length of 40 centimeters. Determine the image distance. So the formula given for this is f, or the focal length, is equal to di times do all over di plus do. Di is the image's distance and do is the object's distance. This is an example of a rational function, and this type of function is defined as having polynomials on both the numerator and the denominator. Now for this question, the independent variables are your object's distance as well as the focal length, while your dependent variables will be the image distance. The first thing we'll do is to substitute all the values in the equation, and from that we get 50x over x plus 50 is equal to 40. Take note that we use the variable x as a substitute for the image distance. The second step is to manipulate the equation such that we get 50x is equal to 40x plus 2000. From this, all we have to do is do some transferring and division, and from that we get x equals 200. This means that your image distance is 200 centimeters from the lens. Now we will move on to the graph. As we see here, the horizontal asymptote for the graph is y equals 50, while the vertical asymptote for this graph is x equals negative 50. The x and y intercept is both at 0, 0. However, it should be taken note that the question assumes that this is for a convex lens, thus the graph must not pass through the negative y-axis. From this, we can now get the domain, which is all real numbers except for 50, and the range, which is from 0 to 50 union with 50 to positive infinity. Now I will give you a new problem. A light bulb is placed at a certain distance from a convex lens, has an image distance of 90 centimeters, while its focal length is 40 centimeters. At what distance was the light bulb placed at? So for this problem, we are looking for the object's distance. We will use the same formula with the first question, substituting the variable x for the object's distance. From that, we get 90x over 90 plus x is equal to 40. Now after a few manipulations, we now get x equals to 72, or we can say that the object is placed at a distance of 72 centimeters from the lens.
Oh, the question is, there was an earthquake in Manila that registered 8.6 on the Richter scale. In the same year, Batangas experienced an earthquake that was 5 times stronger. What was the magnitude of the earthquake in Batangas? We know that the equation for magnitude is m equals log base 10 I over s. M for magnitude, I for intensity of the earthquake, and s for the intensity of the standard earthquake. In this situation, the independent variable is the magnitude and the intensity of Manila, and the dependent variable is the intensity of Batangas. Since the magnitude of Manila is already given, let's set that up first. So, M of Manila equals 8.6, or you can also write it as I of Manila over S is equal to 8.6. Since the magnitude of Manila is 8.6, you can write it as M equals 8.6, or 8.6 equals I of Manila over S. Batangas' earthquake is 5 times stronger than Manila, so you can write it as magnitude of Batangas equals log 5 times intensity of Manila over S. We can expand this and rewrite it as log 5 plus log intensity of Manila over S. Since we know that 8.6 is equal to log intensity of Manila over S, just substitute it. Now the equation looks like magnitude of Batangas equals log 5 plus 8.6. Just input it in the calculator and you'll get an answer of 9.30. If you want to graph this equation, the x-intercept is y0 and the y-intercept is none. There are no zeros. The domain is 0 to infinity and the range is all real numbers. It is asymptotic to the x-axis, so its vertical asymptote is x equals 0. The second question is, if one earthquake is 25 times as intense as another, how much larger is its magnitude on the Richter scale? Let's set I1 as the intensity of the large earthquake and I2 as the intensity of the smaller earthquake. We are trying to determine the ratio of the large magnitude M1 to the small magnitude I2, or M1 minus M2. The reason we are subtracting the magnitudes instead of dividing them is the equation asks how much larger, not how many times larger. First, solve I by multiplying both sides of the equation by I2. And we get I1 equals 25 times I2. We can write M1 minus M2 as log I1 over S minus log I2 over S. Now that we've done that, let's substitute I1 to the answer that we got earlier, which is 25 times I2. Once you input that in the calculator, you'll get an answer of log 25, or 1.4.
Hi Pat, let's do your homework. The time it takes for a pendulum to swing back and forth can be represented by the function s of x is equal to 2 pi square root of x over 32, where s of x is the time in seconds and x is the length of the pendulum in feet. Determine how many seconds it will take for a 7-foot pendulum to swing back and forth one time. In this problem, the independent variable is the length of the pendulum, while the dependent variable is time. This is an example of a radical function. A radical function contains a radical expression with the independent variable, usually x, in the radicand. The first thing that we should do, of course, is to graph the function. S of x is equal to 2 pi square root of x over 32, so that later, everything will run smoothly. So as you can see, using the graph, we can deduce that the domain and range are from 0 inclusive to positive infinity. Why? This is because you cannot put a negative value inside the square root. So, we'll start with 0. Asymptotes are values that the graph approaches but never hits. In this case, it just stops at 0 when you go to the left. Also, it is evident that the x and y intercepts are both found at the origin, which is 0, 0. Meanwhile, as for the asymptotes, there are no asymptotes seen whether it is horizontal or vertical one. Now that the graph is okay, let's proceed in solving the problem. The only given here is the length of pendulum, which is 7 feet. we need to find the time it will take to swing back and forth. So to solve, just substitute the value. S of x is equal to 2 pi square root of x over 32. S of x is equal to 2 pi square root 7 over 32. S of x is equal to 2.93869084. So to simplify, S of x is equal to 2.93 seconds. So the answer is 2.93 seconds. Kind of easy, right? Now I'll give you a problem related to the first one. If it takes 8 seconds for a pendulum to swing back and forth one time, determine the length of the pendulum. This time, the independent variable is time, whilst the dependent variable is the length of the pendulum. Of course, we will still be using the given function earlier, which is S of x is equal to 2 pi square root of x over 32. The only given in the problem is the time, which is 8 seconds. We need to find the length of the pendulum. So, to solve, just substitute the value. 8 is equal to 2 pi square root of x over 32. 4 over pi is equal to square root of x over 32. 32 times 4 over pi squared is equal to x. So now our x is 51.876,44602. So to simplify, that is x is equal to 51.88 feet. Whoa, that would be larger than the size of the big bed. I hope you learned from me today. It is easy, right?